we're starting week 3 here. Today we're going to finish up with searching and sorting in Java and then get into some exercises as much as possible here. But I wanted to bring your attention first to the Gantt chart. Again, this is a completely optional tool if you want to use it to organize yourself and how you should approach this course. However, if you're not good at self-organizing, if you're not good at pacing yourself and spreading work out over a longer period like you should, it might be a good tool for you to start using and start following. For example, our suggestion is by the end of Wednesday, you should be having basically a full second draft or finalized draft of at least 2 of the 3 programs by Wednesday. That's what you should be working on right now. You should be debugging, refactoring, cleaning it up, etc. Just to give yourself 2 days to polish everything up. Make sure, also to pad it out so that if you do hit that roadblock today on Monday, that you've got those extra 2 days at the end to resolve that and get to office hours, to get to help hours, and to get your questions answered. So if you've been following along, if you've been following along with our Gantt chart, that's where you should be. I'd say that you're probably in a good position if the first 2 programs are 100% done, and you've got a really good start on the 3rd program, like you're able to open up the data file and at least display the data or something like that. I'd say that you're probably a little bit ahead if you've got all that. Okay, so. Back to Java over here. Let's go ahead and get rid of this entirely over here. All right, so what we're going to start covering today is searching and sorting, basic searching and sorting. So when we say searching, of course, we mean linear search and binary search. Linear search, of course, meaning that if you've got 1,000,000 elements in an array or a list or something like that, that you start at the beginning and you're searching for that needle in the haystack. If you've got a bunch of integers, you're searching for 5. That's not it, that's not it, that's not it, that's not it, and you go all the way to the end. Right? To do something like that in Java, if I've got the numbers here, right, I need to find an index of it, right? So numbers.index of, right? If I'm searching for that 5, that will give me an index. This is built in, right? You don't roll your own. You don't write your own algorithms for this stuff. So int index is equal to, and then system.out.println index. Right? So where is that element? 0. 1, 2, 3, 4, right? I would expect an index of 4. It's going to find the first index, the first such element, right? So if you've got a list, all you need to do is say, where is it? Index of, and it'll do a basic linear search. For a binary search, however, remember what is the requirement for a binary search? Just to refresh our memories, what does a binary search look like? Well, first of all, what's the requirement for a binary search? It has to be sorted, exactly. Am I going to be able to do that right here with this guy? No. So here's a really quick introduction on how to sort. Collections.sort, numbers, and you are done. Let me go ahead and print that out to show you that it has actually been sorted in ascending order. 0, 1, 2, 3, 4, 5, ... Right? Once I've got that, I can exploit binary search to search this even faster. Right? The way that binary search works is it looks at the middle element first. Assuming that it's sorted, it looks at the middle element. Is that the thing I'm looking for? No, I'm looking for 5, not 4. So in this array, or in this list that's now sorted, where is it, if it exists? Is it in this half of the list, right? The lower half? No, because you know that it's sorted. Where is it? It's somewhere over here. And so you end up recursing, or you end up repeating this pattern where, okay, now I've got this sublist here. Look at the middle element. Is that the thing that you're looking for? Nope. The thing I'm looking for is smaller, so it would be among these 2, right? Among this one, and finally you narrow in on it. That's what binary search is, okay? So how do we go about doing that? Index is equal to, well, guess what? Collections.binary search is also there, right? The thing that you're searching for is going to be the thing that you are searching in your haystack is going to be the first argument here, and then the thing that you're searching for is the key, the second argument here. Let me go ahead and print that out and show you that it's now at a different index. Hopefully, right? It's at index 6 because it has been sorted. 0, 1, 2, 3, 4, 5, 6. Right? Note there we've got repeated 3s. Okay. That's basic searching and sorting. You've got collections.sort, and you've got, if it's a list, of course you can go index of. If you've got a set, then you have to ask a different question. There is no ordering on a set, so you'd ask, does it contain that element? Right? It also works equally well for strings. Let me go ahead and create a list of names here instead. Names, and this won't be a list of integers anymore, it'll be a list of strings, okay? And we can't give it a bunch of numbers, integers. If it's a list of strings, we need to give it actual strings here. So let me go with Bob, Chris, Anita, I don't know, Grace, Zeno. There we go. And let me go ahead and do one more Bob here. But I misspelled his name, or I've got a lowercase b here. Let me go ahead and sort this. Collections.sort. Names. Now let me go ahead and print them out before and after, showing that before it's not sorted and after it is sorted. Predict, however, what's the first one going to be here? Sorted, all these names are sorted now. Anita should be first, right? All right. And then Bob, then Chris, then Grace, then Zeno there. But what about that lowercase b Bob? Is he right next to the other Bob? Let's find out. No, he's not. He's way at the end. Why? It's the ASCII text table, exactly. It's lexicographic order. The lexicographic order means that in the ASCII text table, if you've never seen it before, just go to ASCIItable.com, all right, ASCIItable.com, and you can see what the ASCII table looks like. Where are all the capital letters? A through Z. They come before the lowercase letters A through Z, right? And that's why it is sorting them with respect to the ASCII text table. Well, if that's not what you want, what you need is a custom sort. So everything above here, I'll just embed this in the notes directly. Everything above is the natural order sorting, right? In other words, it sorts in ascending order, right? Uses lexicographic, etc. Right? These are all naturally orderable. If I had a bunch of doubles, it would sort them in ascending order. What if I want descending order? You don't call that unnatural, you just call that artificial, right? What if I want to sort these names with respect to their the dictionary order? Rather than relying on the ASCII text table, I do want those two Bobs right next to each other, right? So to do that, what I need to do is I need to define a comparator. To get an artificial ordering, you need to create a ... Now, for those of you coming from a C background, we created this function that had this following pattern. That I've got A and B. If they're in order, A comes before B, it returns something negative. If they're out of order, B comes after A, right? Then it returns something positive. If they're equal, it returns something, well, something 0, right? So negative, positive, 0. That was called a what? A comparator function, right? For C, we're going to use a comparator. Right? Now, for those of you coming from a Python background, how would you normally do this? There's sort and then there's sorted. Both of them would take a lambda function, right? Or a key. I want you to use that thing over there. Or if it was naturally orderable, like this all is up here, then it would sort. It would naturally order it and sort in ascending order. If you want it in descending order, then there's another thing that you can put in there called reversed is equal to true, right? We're going to do the same thing here, but instead of using a lambda function, we're going to define a full comparator class. The pattern is as follows. It returns, if A is less, it returns something negative. If A comes before B, it returns something positive. And note there, I'm trying to emphasize something. Don't read anything into it in general. In Java, you can, because if you read the documentation, it says that the magnitude, you can actually get more information out of the magnitude. Don't worry about it. We're just going to be looking at negative and positive here. if A comes before B, right? And right in the middle there, it returns 0 if A is equal to B, right? Conceptually. Right? So negative, positive, 0, depending on the relative ordering of those things. Every single programming language has something like this, right? The vast majority of them follow this exact same pattern. Python's a little bit different in that if you just want to do it simply on one key, then you would create a Lambda function to do it. If you want to do something way more complex, then you would bring in the total ordering library to do it. Don't worry about it, all right? All right, this is going to be our pattern. Now, my first attempt here, example. Let's go ahead and create a comparator that orders integers in descending order. Okay? To do that, I'm going to go ahead and go with comparator C. Give it a proper name, right? CMP integers in descending order, right? Is equal to new comparator, and it's going to be a comparator for integers. Oops, that's something I forgot to put over here. It needs to be a comparator for integers so that you can use it on a list for integers. Like things need to be comparable to like things. If I have a comparator for strings, which we'll do in a moment, could I use that to sort a bunch of integers? No, they're completely different types. So this will be my comparator for integers in descending order. Here's the rest of the syntax. This is something completely new, probably to everybody in here. This is called an anonymous inline class declaration, right? It is very much like a Lambda function if you covered Lambda functions in Python. A Lambda function is nothing more than a fancy name for a function that doesn't have a name. This is a class that doesn't have a name. Let me go ahead and add the unimplemented methods here, and we'll take care of it in a second. I could put this comparator and this functionality that I'm about to write, and I could put it over in this class called my awesome integer comparator that sorts them in descending order, right? And that would be a very, very long name for that class. Why? It does one thing. It takes two integers, A and B, and it says they go like this, or like this. It does one thing. It has one purpose. Why put it into a class? We'll get to classes later on, but there's no point, right? Just go ahead and make a single instance of this in line, creating a new comparator, okay? So let me go ahead and implement the logic now. Given those two values, I want to make them go like this, or this, but in descending order. So if A is less than B, are they in the right order? No. If they're not in the right order, what would I return? Something positive. You can put a plus in front of it. It looks weird. Don't do it. Right? Else if A is greater than B, are they in order? A is great. So 10, 5. Remember, it's in descending order. Right? Or 5, 2, since I don't have that many fingers. Are they in order? Yep. So return something negative. 1, right? Else, return 0. Right? Once I've got that comparator, now I can use it. Let me come back up here and resort those values. So let's see, collections.sort. I want the numbers. Right? Now, instead of sorting it in the natural order, I'm going to also provide it my comparator right here as a second argument. When I do that, I get a descending order version of that list. Sort it, resort it, scramble it up if you want to, do whatever you want with it. But now it's in descending order. Now, let's go ahead and create another comparator, another example here. Create a comparator for strings that orders them in increasing, technically non-decreasing order, but ignoring case, right? Case insensitive ordering, okay? So here's a comparator, right? And what is it? A comparator is not a real name, right? You won't find it in the dictionary. Instead, we make up names. It's a comparison. Well, what is the verb form of comparison? Comparing, right? That would be the gerund, though, and so that's not right either. We just need a new thing, so we make up a name for it, right? So this is going to be a comparator for strings. Give it a name. Should I call it CMP int? No. str, right? Case insensitive. name it whatever it is, right? And a new comparator. There we go. All right. And end it with a semicolon. Why? Because if you create int x is equal to 42, it ends with a semicolon. That is an executable statement. This is also an executable statement. This is a comparator. X is equal to, instead of 42, I am giving it a definition right here. And that has to be ended with a semicolon. If you just highlight this, it'll auto-generate this code for you. I don't like calling them O1 and O2. Those are the defaults. I like calling them A and B, A and B, so that I get them correct, right? Now, what I could do is I could have that if-else-if statement, if A dot compare to ignores case, right, of B is less than 0. But guess what? Everything in the language follows the same pattern. Something negative, positive, or 0, depending on the relative ordering of these things. If I just say that A is, I'm going to compare that, ignoring the case, to B, it's going to also return something negative, positive, or 0, depending on the relative ordering of it. So all I need to do is capture that value and return it. There we go. Right. Much, much simpler. Okay? Now let's go ahead and sort those to, resort the names. You'll see here that it won't compile because names is a list of strings. And I have not changed the comparator yet. It's a comparator for integers. And so it won't compile. Those two things are not compatible. So let me go ahead and grab this one and change the comparator so that they are compatible. Now remember, Bob was at the end right here, right? Now that I'm using this custom comparator, this artificial ordering, Bob is right next to the other Bob. Don't read anything into lowercase bob being first or last or whatever, because you said you're going to ignore the case. What about ties? Well, if I've got Bob and Bob, how do I break that tie? I don't know. Then you need to rewrite your own comparator, right? You need to put that logic into this comparator, okay? That is basic searching and sorting. Here is a nice shortcut. New modern Java shortcut. Right? So what I want is I want a comparator for integers, right? And I'll just call it CMP int descending, and I'll spell it all out because I can't reuse that variable name. So I'll go ahead and go with comparator dot reverse order. Right? So just like in Python, you can say, I want sort or sorted, and then reverse equals true. You can do the same thing here in modern Java. Right? What about comparator for strings? CMP string easy is equal to comparator dot comparing string and what I call it, ignores case. I think you can do this. I hope you can do this. There we go. Come on, please. Comparing string. Then compare. Nope. I'm not going to be able to do this. Nope, I'm not going to be able to do that. I'll show you in a better way, but that's one way that you can do it in the reversed order. I don't know how to do it off the top of my head, but I will show you a better way of doing this later on when we actually do an exercise, which is what we're going to do next. Before I do that, though, any questions on searching and sorting? Another thing to keep in mind is binary search. So, for example, for those that have already started on the third exercise of the first assignment, that is a data crunching assignment, right? The example that we give you is like 47 data points. If you write out your program and it works perfectly, great. But when you put it on the grader, you're going to have tens of millions of data points. And if you've got something slow, like a linear search, it ain't going to work, right? If you have something fast, like binary search, right, then it will work. Or if you use a smart data structure, like a map, right? So you need to think about how we've used maps up to this point, how we might use them in an exercise that we're about to do, how you might use searching and sorting to speed the process up. Because if you do have a correct program, great. It works on the small sample size of 47 data points or something. But then when it goes to 10 million, oh, wow, it's taking forever. And eventually 5 minutes on the grader, it times out and kills your program because it would have taken weeks to execute, literally weeks to execute, because you're using some linear search or something like that. Right? All right. I'll make sure that you have all this in the notes. There we go. And bring it over here. And what I want to do now is I want to motivate the last part of this Java coverage with an exercise. All right, so exercise. Let's go ahead and create a class to represent books and create some basic reports. The reports that I want are what is the best book, worst book, what else? All books by a certain author, etc. Or a book by a certain author, etc. Okay? Now to motivate this, what I'm going to do is I'm going to share some data with you here. Let's go ahead and create a new file. And I'm just going to call it books.csv. CSV, of course, being a comma-separated value file, which it wants to really open up with Excel over here, so I'm going to tell it no. And where are my books here? There we go. All right, so open up this file. You can drag and drop it onto the Eclipse editor to force it to open up in Eclipse, and then you can work with it. So I've got 20 books here. All this data was pulled off of Goodreads.com. On the first line here, we're telling you exactly how many books there are. Right? Just like in your assignment, we're telling you exactly how many data points there are. If you ignore that line, great. What happens when you come down here to line 22? Is there a book there anymore? And so you'll start screaming, oh, wait, my program is not running. There must be bad data. No, you ignored the first line. Don't ignore the first line. Right? Otherwise, it's CSV data. We clearly have a bunch of book data here. The first token here is going to be a title. The second token is going to be the author's first name. The third is going to be the author's last name, the release year, and then the Goodreads user rating. I think it's on a scale of 0 to 5. So this is a highly rated book. Some other things are not so highly rated, right? There's probably the worst book right there, 2.33. But what I want to do is I want to load this data up and have a representation in memory of how to do this. Right? Then I can start running my reports. What's the worst book? What's the best book? Give me all the books by, I don't know, Robert Heinlein here. Right? There are several of them, but maybe we're just satisfied with one. Okay? There's my data. Over here in demo, how should I represent my data? Right? So remember that a book is 5 pieces of data. Anytime you see yourself representing one thing, one entity with multiple pieces of data, that should be screaming out to you to encapsulate them into one unit. For those coming from a C background, what is that unit of code? A structure. For those coming from a Python background, what is it? A class, just like Java here. Right? So what I want to do is I want to start by representing my data. Instead of a top-down question, a top-down solution where I break up the problem into its constituent parts until it's solvable, I want to start at the bottom. How do I even represent this data? Before I even write any code to process this file, I want a representation of that data. To do that, I'm going to go ahead and create a new class. Well, this class is going to represent a book. So what should I call it? It ain't that hard. Book, right? Don't call it books. Why? This is going to be a blueprint for creating multiple books. You don't pluralize the blueprint, right? If you're in a factory and you're creating widgets, it's a widget factory. It's not widgets factory, right? So I'm going to go ahead and create a book. Note there that I am uppercasing it. All class names in Java should be upper camel-cased. So that if I had book, hello, world, right? It should look like that. Don't name things like that. Gross. Right? Okay. Now tell me what represents a book. What pieces of data define a book, at least as far as this report is concerned? What's that first piece of data? A title. And what is title? Is it a number? Is it a string? All right, title. There we go. So I've got title, and then out over here I've got semicolon. Wait a second, we're not main anymore, are we? Right? This is what's known as a member variable. This is a variable that belongs to an instance of a book. You can see here that we're going to make 20 different books. Each one of them has their own title. This is a blueprint for creating a book with its own title, so that that book over there has a title, that book over there has a title, that book over there has a different title. Every single one of them has a different title. What's the other one? String, author, first name. There we go. String, author, last name. All right. What else was there? Release year. Is that a string? String, year, right? It's equal to 1985 or something like that. Is that a good way of representing year data? Probably not. Right? Let's go ahead and change it to an integer so that it represents a year, 1985 or whatever, right? What's another way? Maybe I do want a string. Right? For example, in your assignment, how do we represent dates and times in your assignment? Date time is equal to this thing called 2023, what is it right now? 0206. Time, and right now it is 10:56 CDT, right? 10:56 and 40 seconds and a half second, something like that. That's an ISO 8601 format. It is a string, right? Don't get bogged down in the details on your assignments, right? Treat those things as strings and you'll be good. Why? The whole reason we define ISO 8601, that standard, is because when it's a string, it is lexicographically ordered. If I went collections.sort, if I went collections.binary search, right, using the string representation, it is straightforward, it is automatic, right? If you're European, how do you represent today's date? Wrong date. It would be what? Isn't it day, year, month? 06, 02, or 2023, something like that. That's wrong, right? If you're American, wrong, right? If you're an American and you get it wrong, it's going to be 0206, 06 to 2023, right? That's also wrong. Why are both Europeans and Americans wrong? Because it is not lexicographical sortable. You then need to actually parse out the string, pull out those 3 pieces of data, and then make your comparison. The ISO 8601, computer scientists, computer engineers, software engineers, whatever you want to call yourselves, we're the only ones that get it right. So keep that in mind, right? Because it's the ISO 8601 standard. For now, though, we'll just go ahead and go with a year, right? Because the point of this exercise is to process this file and do some searching and sorting. Now, what about that rating? So is that an integer? Clearly not. It should be what? A double. Oh, it could be a string. Right. Yeah, the 3.14. That's ugly. Why? Because then we can't. Oh, the whole line is certainly a string. We'll need to process each one of those tokens. But representing a book here, it's going to be just a double. Okay. Now let me come over here to the demo and create just one book. Book B is equal to new book. Right. This is called a constructor. We've been using this implicitly up to this point, and now let's explicitly talk about it. If you've got a built-in type like an integer, a double, or a string, you can use just a regular old assignment operator. If I just say int x is equal to 42, right? It's built into the language. It's a primitive type. Right? It is built into the language, so the compiler, the system, the language, it knows how to take 42, convert it into binary, store it in a memory location that it knows about. Right? That's not the case with a user-defined type like book. Right? How do I create a book? I'm Java now. How do I create a book? I don't know. You need to specify that. You as the user, as the designer of this class over here. So those coming from a Python background, how did you do it in Python? You talked about classes in Python, right? Yes? No? Yes? Okay. You had this thing called underscore underscore init, right? Underscore underscore, something like that. That was called a constructor or initializer. We're going to do the same thing here. Now, if I just do this, right, it's like a lawyer. If you can't afford one, if you don't define one, one will be provided for you. And this is called the default constructor, right? If you don't define a constructor, a default constructor takes over, and what does it look like? System.out.println b, right? Let me go ahead and run this. Have we defined any data at all? No. So it just is this mysterious memory address. If I tried to do something like, well, what's b's title? .title, right? That should look familiar for everybody in here. A structure, you use the dot operator. Python, if you've got a class, you use the dot operator, right? If I output this, is it defined yet? No. Right? So the default constructor here defines default defaults. Null, 0, right? In fact, I can tell you that these three are going to be null. This one is going to be 0, and this one's going to be 0.0 because those are the defaults, right? If I were to print each one of those out. I don't want to have to do that. What I want to do is I want to specify, here's the title. Right? In fact, let me grab this data here, just for the first, nah, that's not a good one. That's a middling one, but I'll go ahead and use it. Right? Books, that is, right? In my opinion, right? There we go. Middling at best here. Sorry, Patrick, but you need to get to work on the last one. Does anybody read? Okay, all right. Somebody knows what I'm talking about. All right, so there we go. It's not going to work here because I've not defined a constructor that takes the title, the first name, the last name, the year, and the rating. Right? So let's do that now. Right? What I'm going to do is I'm going to create a public book that takes a string, title, a string, author, first name, ... And I'm not even going to bother finishing this because I hate typing, right? Everybody here hates typing, right? I'm not going to do that. Instead, I'm going to use what the IDE provides to me. Ooh, the magic of ChatGPT, right? If I can define I want you to, ChatGPT, I want you to give me a book class that has these items. Oh, wow, it mysteriously and magically generated this code to do it. We've been doing that for 20 years with IDEs. Who cares? All you have to do is go up to source, generate getters and, or not generate getters and setters yet. Source, generate constructor using fields. All of them are selected. If you don't want one of them, deselect it. Hit generate, and oh, I didn't have to type a single damn line of code. Right? There we go. Don't worry about the super, it's optional. We'll talk about it later. Otherwise, there's everything that I would have typed if I had wasted my time typing, okay? Now let's come back over here and check it out. Excellent. Now I can create books. If I run this, I can see, well, here, I need to actually print it out or something. System.out.println b, there we go. Run this, and we can see that we get the same result. But if I printed out the title, you can see that the value of the title has now been set. Name of the wind. That was the magic of this constructor over here that was automatically generated. Public, it is a function, but is there a return type? Like void, or I want to return a book? No. Why? Because it's a constructor. It constructs instances of this class. So there is no return type because that would be redundant. I am the book constructor and I create books for you, right? Why do I repeat myself, right? So instead, all constructors are simply named after the class. If I name this something else and misspelled it, book, right? Then it is not a constructor at all. And I've got a syntax over here, error over here. Now, there is no constructor that takes these 5 things, right? So it has to be named after the class that you created. One other thing here. What is that this keyword? Right? To illustrate what that is, what I'm going to do is I'm going to delete it. In fact, I'm going to delete all of them. Right? Here's some IDE magic. Oh, not that much, but there. Delete, there. All right, wow, was that amazing? Oh, that was not amazing? Oh, okay, so you don't want to know how to do it. Oh, okay, that was block selection mode. Most IDEs, most code editors will allow you to do something like this. Normally, it's line selection mode, right? Because all the normal people, they just need to do plain old English. They don't need to do fancy stuff like data processing and stuff like that. And so they don't have block selection mode. In Eclipse, you've got Option Command A to go in and out of block selection mode. For those on Windows, I believe, but don't quote me, I think it's going to be Alt Control A, right? I forget what it is. But that'll send you into block selection mode where you can go this dot, right? You can select columns of data, copy those columns, and then move them over somewhere, right? You can do stuff like that. Oops, and then undo, undo, undo because I accidentally typed too much or selected the wrong things, right? But let's go ahead and just get rid of this one for now. Now it's giving me a big giant warning here. If you read this, it's going to tell you that the assignment up to a variable has no effect. At this point in the code on line 13, how many variables do you see that are named title? 1, the parameter, and 2, the member variable name. So what it's complaining about right here is that you're assigning the variable to itself. It would be doing something like this. Int x is equal to 42. X is equal to x. It's the same exact warning here. Why are you doing this? Yes, you can do that, but that looks weird. Why? Right? All you're doing is taking whatever's stored in x and you're putting it right back into x. That's where this warning is coming from. It's saying that all you're doing is taking the value stored in this parameter and putting it back into the parameter. You're not actually setting this title to that title, right? Let me go ahead and illustrate this with that title, right? Instead of title. So this dot title is equal to that title. Right? Now it should be clear what I'm trying to do. I'm taking that variable that's passed into this constructor and I'm putting it into this book's title. That's where the this keyword comes in. It is a self-reference. It's called open recursion. If I'm in the book over here in this demo class, that book that I just created is referred to as B. That's the variable name. But if I jumped into this class, do you see that variable anywhere here? No. I need a way to refer to myself. If I'm a human, I say me, myself, I. I don't say Chris. Chris did this. Chris did a lecture. Chris has another lecture right after this that he has to get to, right? You can, but then I'm speaking in the third person, right? And you're weird. Well, this book needs a way to refer to themselves, but it's not a person, so they can't use me, myself, and I. It's an object. So how does an object refer to themselves? This, right? Because it's not an anthropomorphized person, right? And that's what we're doing right here, title. It's all auto-generated if you just let the IDE take care of itself, okay? Let's come back over here and let's try to run this. Again, oops, I just want to print out the book itself, right? Just like I've been doing with everything built into the language up to this point. That ain't gonna work, right? Those of you coming from a Python background will recognize something like this. If you just create a class, like a student class, and you try to print it out, is it gonna be nice and pretty? Nope, unless you use the pprint library, pprint, pretty print, right? So what is this thing right here, this hexadecimal thing? And by the way, it's probably going to be the same every single time because Java Virtual Machines memory is the same every single time. This is a memory address, right? Just like it would happen in Python. In C, you don't even have this luxury. You have to do everything from scratch, right? But at least this is being given to us. So over here in the book class, I want to add functionality that if you print out this book, it prints out the actual data over here. Right? So start typing. No, we only have 10 minutes left. Guess what? Source. Generate toString. That'll get me started. It ain't going to be pretty though. Right? It's going to look something like this. So that if I come over here to demo and print this out, it's going to print something that looks like this, just like the pprint library would do in Python. Right? That's not what I want. I want it to be nicer looking. Okay, fine. All you have to do is define what you return as a string representation of this. Public, it has to return a string, and it's a toString method. By default, it returns this weird hexadecimal representation, the place where it's stored in memory. We don't want that. We want it formatted in a way. String.format. So unfortunately, they called it format instead of what it should have been, printf. Right? Those coming from a C background, you'll recognize this as sprintf. Printf, but you're printing to an S. An S is a string. Right? Those coming from a Python background, you use an F string to do something like this. Put F in front of it and then format everything inside of it. Right? But here it's string.format, which will return a string representation of a title, %s, by %s, comma %s. So that will be this dot title, right? This dot author last name, comma first name. This dot author, first name, and then we'll go ahead in 2007 or whatever it was. %d is the placeholder for an integer, and in parentheses here, let's put its Goodreads rating, but only out to 2 decimal places because that's all they report. Right? And so first name, this dot release year, this dot rating. There we go. And now, what are you complaining about? Semicolon. Can't see it at the end. You can break up long lines. It's perfectly fine. It's perfectly acceptable. If you want to, you can break them all up, and just make sure that they're nicely aligned so that you can see the ordering there. That's a nice way of doing it. Why? Because you can go into block selection mode and edit it column by column if you want to. Now when I come over here to demo, it's not that garbage. It's now the way that I wanted it formatted. The title by Rothfuss Patrick in 2007 with that rating right there. Excellent. Now, before we get into back into file I/O, to process this file and create 20 books here, let me show you something else really quick, since we only have about 7 minutes now. What if I change the title? B dot, or the rating or something like that. Let's say change the title, right? Some book. There we go. And then I printed it out again. There. Now it's Some Book by Rothfuss Patrick, 2007, right? The sequel was what? Do I have it in here? Yeah, 2011. And so now it's been 12 years. It's supposed to be a trilogy that has not yet come out. All right, so Some Book, right? Is that a good idea? So that's how you have to deal with things in both of the languages that you're familiar with. In C, you can do whatever you want with your structure. You can change it however you want. With Python, if you've got a class, book here, you can go ahead and do this all day long, right? You can say b.title is equal to whatever I want, including, say, deleting it entirely and setting it equal to null, right? Those coming from a C background will recognize the exact same concept. It's just going to be uppercased. Those coming from a Python background will also recognize the exact same concept, except that you called it none. Right? This is null. Right? Should I be allowed to do something like this? Null by Rothfuss Patrick. I don't think so. Right? So what we've done over here is called encapsulation. Right? Encapsulation is actually 3 things. It's the grouping of data. That's what we've done here. That's what you do with structures in C. That's what you do with classes in Python. But that's weak encapsulation. Strong encapsulation has 2 more things. It has the protection of the data, and it has the grouping of methods that act on that data. We'll get into that third part later on. What I want to do is I want to protect this data. I don't want you to be changing the title to whatever you want, whenever you want, wherever you want. I'm going to make it private. The alternative here would, of course, be public. Anybody can see the title, anybody can change the title, anybody can do whatever they want to the title. I want to protect this and make it private. So that over here in the demo class, now you're not able to do that. You can do that if you really wanted to with, when you actually constructed this thing, right? Null. Then you may want to do data validation. That's the last thing we'll do here in a moment. But you won't be able to do that later on. So now you can't do that. by making this private. Unless you have a very good reason, every single variable should be private. You should protect those things by making them private and then only allowing access to the outside world through what are called getters. For that, I'm going to go back up here and generate getters and setters, except I'm only going to do the getters. There we go. If you really want the title, I'll give you the title, but I'm not going to let you change it. If you really want the author's first name, I'll let you have it, but I'm not going to let you change it. I've protected this data now. Right? I've created a class with strong encapsulation that group the data together, but I've also protected it from bungling fools that want to change it. Okay? If you want to protect yourself further from bungling fools that would set the title to null, you can do that through basic error handling. If the title that you give me is null, I'm not going to throw a null pointer. I'm going to throw a new illegal argument exception. This is an unchecked exception that they can surround with a try-catch or not, depending on what they want to do. You cannot create a book with no title, right? There. Otherwise, if you give me a valid title, I'll go ahead and use it. Over here, let's try to run this, and we see that we get that error. No, you cannot handle that book. You cannot create that book class. Right? So change it back. Undo, undo, undo. There we go. And undo that. And it works, right? Exactly as before. I am protecting my data and giving myself a chance to validate that data. No, you cannot create an instance without a title. Right? Now, don't go crazy and just think, okay, well, I'll never allow nulls, never allow nulls, never allow nulls. Cut and paste this code, cut and paste that code, cut and paste that code. If you, I mean, this is not necessary, right? If you want to allow them to go ahead and willy-nilly create bad data, then that's on them, right? But if you want to absolutely enforce that, then yes, absolutely, you need to write that code to do it. But give access to the outside world to allow them to have that data when they need it. Best of both worlds now. We've got strong encapsulation. So next time what we'll do is we will go back to file.io, create all the instances of all these things, and then create the reports. What's the best book? What's the worst book? Think about how you can use searching and sorting to be able to do that.